Okay, boys and girls, we will continue our lesson. But today, a lot of friends haven't come in yet. But it's okay lah. We cannot wait for them anymore. Okay, so we will continue lesson number 18. Lesson number 18, the day we stop on page number 6. We finished page number 6. So now we continue with page number 7, conservations of energy. Okay, conserve that means that it will be remain the same. So principle of conservation of energy state that the energy cannot be created, cannot be destroyed. Okay, it can be only transferred from one store to another. So we already learned about energy store, so they can transfer from one way to another way. Total amount of energy in different energy store before and after must be the same. This is the meaning of conservation of energy. Okay, then at here we can using Sankey diagram to represent the energy transfer. So let's say here is 100%. Okay, so when we transfer, some of them goes to the useful. Okay, this part normally go straight is the useful one. For example, here 100%. So here maybe like 40%. Okay, or 30%, 30%. Okay, 30%. So here maybe like another 30, 40%. So 30 plus 40 is 70. So there is another 30 somewhere here. So no matter how at the end, input energy is equals to the output energy. Okay. So from here, the input here is total. We write down total input energy. Okay. At the front part actually is total input energy. So let's say at here I say that is 100%. Starting is 100%. But not all 100% goes to one form, another form. It might be goes to others form. So at here, go straight one most of the time. Here we will use it to represent useful energy. Useful output energy. Useful output energy. So in this case, maybe like we put it 30% now, okay? 30%. Then after that, here the blue color one, actually we can use it to represent wasted energy. For example, here let's say it's 30%. Okay, then this one also another type of wasted energy. For example, some of the application we might be like energy lost to the surrounding as heat, thermal, as sound. So these two type we don't want, but we cannot avoid. Okay, it's a wasted energy, output energy. So we will draw in this way. So just now we said that principle of conservation of energy. Energy must be conserved. Okay, before and after must be remain the same. So before that is 100%. Okay, then after that useful one is 30%. Let's say only 30%. Wasted here is 30%. Then here in order to fulfill, then 30, 30. Then this one must be 40. For example, 40. Okay, but of course here maybe we can put it like 45. Okay, 45%. So 75. So this one is 25%. Okay, why I change a little bit because this part it seems like wider. Okay, so I change it to make it bigger than 30%. Okay, so this one is narrower than this. So at the end 25 is less than 30%. Like this proportional, its proportion is more makes sense. Okay, so at here Sankey diagram can helping us to represent how the energy transfer. Okay, from the input transfer to another three form. So most of the time, the wasted energy will be the thermal and the sound energy, like in most of the case. Okay. Okay. So here, a modern energy efficient light bulb. Okay. For example, starting provided electrical energy provided is 100 joule. Okay. Then light bulb, of course, what is the energy we want? We want light energy. We want the bulb lights up, so it's light energy. This is the useful one. We found that will transfer 100 joule. Not all the 100 joule goes to the light. It has some of the joule is going actually to the surrounding. okay, is lost to the surrounding. So for example, 25 joule, which is the heat energy. Okay, so at here, the 100 joule equals to the final 75 plus the 25. So we get back 100 joule. Energy cannot simply destroy, or we cannot create it. Okay, starting 100, at the end still 100. Okay, it's just how they distribute to others energy only. So second case, an old filament light bulb. Okay, this one is old type. Input also 100 joule. Okay, but the way they convert, we found out that the 100 joule, only 10 joule goes to the light energy. The rest of the 90 joule goes to the heat energy. So if we compare these two, okay, as a consumer, how we choose? We should choose the modern energy efficient light bulb. Because from this diagram, we understand that most of the energy actually is the useful output energy. Most of the input energy actually is converted to the useful output energy. But the older one, the old one, filament one, this one is only 10 joule. Most of the energy actually goes to the surrounding as heat. Okay, so from here we understand how we choose a good or more efficient light bulb. Okay, any question? If no question, we goes to page number 8. Okay, there is a reaction button. Okay, Crystal, okay, okay, Zihua, okay. Okay, dear, here, page number 8. This is the example. Okay, energy transfer useful from kinetic store. Okay, then after that to the kinetic store, because transfer energy to the ball. So the ball will move and it will gain the kinetic energy. Energy is also dissipated, loss. Okay, dissipated means loss, or we say wasted to the thermal store of the bat ball and surrounding. Okay, so how the energy change? Not all the energy of the bat goes to the ball, but somehow it will go to the surrounding also. Okay, so there is another common case of the principle of conservation of energy is the pendulum swinging. Okay, most of the times for this case, we will take this point as the position, starting position. Okay, this position is 0. So from here goes to the C point, it got the certain height, certain position. So that means that at C point at here, we pull the ball, we pull the pendulum at here, then we release. So the pendulum will swing. Okay, but at this point, it's not moving. This is the highest position, not moving yet. Okay, so at this point C, okay, at point C, at point C, so at here, at C, what kinds of energy it has? So it will have GPE. Okay, at this point is GPE. There is no kinetic energy, which is here lah. Okay, GPE, no kinetic energy. But after that, it swings, start to swing. So your GPE, it will decrease because the position going down, the height going down until here, no more height because we take this point as our starting position. Okay, so until this point, all the GPE will converted to here. What kinds of energy we gain? We will get to kinetic energy. Okay, it will swing, and until this point, this is the highest speed or highest velocity. Okay, so all the MGH, okay, all the GPE, it will be converted to kinetic energy at point C to A. Okay, so GPE will decrease, but kinetic energy will start to increase at position A. So until position A, in normal position, in normal height, okay, so GPE becomes 0. All the energy it gain actually is kinetic energy right now. At position A, it's GPE. It's kinetic energy, not GPI. It's kinetic energy. Okay, then from C swing to A, then from A swing to B. So you can know that now we again start to increase our height. Okay, start to increase our height. That means that our MGH will start to increase. Our GPE will start to increase. So at this position, A to B, A swing to B, kinetic energy will start to change to GPE. Will start to change to GPE. So your speed will decreases. You going up, your speed will decreases because you're against gravity. Okay, and then some of the energy actually goes to GPE. Okay, so for this case, your kinetic energy will start to decrease and your GPE will start to gain. So at position B, all the energy is actually come from the GPE. No kinetic energy. Okay, at position A, your all the energy actually is kinetic energy. At your position C, actually also GPE. But in between the swing from C to A, we are using GPE, decrease and convert to kinetic energy. From A to B, actually is kinetic energy convert to GPE. Okay, for this case, any of you got any question want to ask me? Any question you want to ask me? We take this point as starting position. So we swing from highest point. GPE will start to decrease and then we gain kinetic energy. Here is the maximum kinetic energy. Then kinetic energy decrease. We start to swing up. It will decrease because it again gravity. So what it gain? It gain GPE because it got certain position hedge. Okay. Except Hui Tong, any others got any question? If no question, you give me the response, then we will try the past year question. Crystal, okay? Megan, okay, we try with past year question. Okay, let's go. Okay, energy transfer. Which energy transfer take place when the petrol is burned? Petrol. What kinds of energy due to the petrol? And what the energy we will gain transfer to? Try and then tell me your answer. Hmm? What is your answer, dear? Okay, Zihua correct. Petrol is chemical. We burn the petrol, burn. So it must have the heat. Okay, so answer should be A. The energy transfer should be A. Okay, question number 2. This is last year past year question, 2024. A ball is falling towards, so to the ground. It's falling towards to the ground. So here is the ground. Okay, which transfer between energy store is happening? What do you think? From what to what? Crystal? Crystal correct. From C, GPE. So as starting, falling, dear, falling. Falling, that means that it got certain position. Certain height. So this one, it should be GPE at here. Okay, falling. So at here, we understand it will accelerate 9.8 meter per second square, right? It will accelerate. Accelerate means what? Speed increase. Speed increase means what? Kinetic energy will increase. Okay, so at the end comes to this point, the energy it have is called kinetic energy. All the GPE will be converted to become kinetic energy. So answer should be C. Okay, answer should be C. Okay, can I proceed to the question number 3? Okay, a child push a toy car along a horizontal surface and then release it. As the car slow down, what is the main energy transfer? Slow downs. It slow down. So what energy transfer? Crystal? No, Crystal. Crystal, are you answering question number 3? Zihua. No, Crystal, it's horizontal surface. So your answer is wrong. Zihua, correct. Horizontal surface, that means that like this. So this is the car. Let's say this is the car. Okay, it push. Apply the force and push. So the car will move what? Okay, the car will move and then it slow down. At the end, at a certain point, it stop. Okay, so from here, we understand it push, it will move. How I know it move? Because it slow down. That means it's moving what? Right? It's moving. So at here, Crystal correct. So it's moving. So that means that it move kinetic energy. But at the end, why it slow down? Slow down is because of the friction. Friction. There is a friction cause the things to slow down. Okay, we apply the brake for the car or whatever. We driving the car, bicycle, we apply the brake. So at the end, we can stop is because there is a friction between the tire and the road. Okay, so slow down is because friction. Friction will produce what? Heat. Okay, you use both of your hand, then you touching each other, then you rub. Okay, then at the end you touch your face, you will find that your hand actually is warmer. Okay, this is because of the friction creates some heat energy. So actually at here your answer should be donkey. Okay, it's not GPE, gravitational potential. This is wrong. It's because we didn't increase the height. Unless for this case is they are like this. Okay, this is the car. So it push at the end, final at here, it gain the certain position. Okay, here from here to here is the certain position hatch. Then we can say that kinetic energy converted to GPE. But then at here, we didn't consider with the, okay, this one can be adding up the thermal. Okay, thermal, because it slow down and then it gains some certain position, certain height. So for C, unless the question is like this, then we only choose C. Here is horizontal surface. It doesn't increase any height position, so it cannot be GPE. It's donkey. Okay, is it okay, dear? If no question, we goes to page number 10. Is it okay? Okay, Hui-Tong okay. Megan okay. Okay. Okay, then we goes to question number 4. The diagram show part of a roller coaster, right, with the car at different position. The car runs freely down from position X to position Y and up the hill on the another side. Okay, what happened to the kinetic energy and GP of the cars as it moved from position X to Y? Okay, at position X to Y, what happened to their kinetic energy? From here to here, what happened to kinetic energy? What happened to the GPE? Okay, let me check Hui Tong answer. Hui Tong correct. Crystal correct. What's the first answer? First answer. First answer is A. Sure, first answer is A. Is it okay? Zihua correct. Xuan, is it you're asking for this question? Okay, done? Okay, my dear. Question number 4. Okay, at this position, you see we got a certain height hatch position. So this one must be a GPE. Okay, GPE. So at position Y, this point is the lowest point. So at here, we no more GPE. All the energy convert to kinetic energy. From here, convert to kinetic energy. Okay, that means that GPE will decrease. Kinetic energy will increase. Why, teacher, we understand that it will convert to kinetic energy is because it going down, gravity pulling, it will accelerate. Object will accelerate when it going down from a certain position, it going down. It will accelerate. Accelerate meaning that speed increase. Speed increase, kinetic energy increase. So answer should be C. Okay. Then we goes to the question number 5. This is also last year question, 2024. Two identical trolley P and Q hold at rest at frictionless horizontal surface. A load is fixed. Oh, okay, there is a load at here, okay? Fixed to the trolley P. State the energy transfer that happen as the spring expand. So this one is compressed. When compressed spring, what is the energy store? Can you tell me what energy store in the compressed spring? Any of you know? This is what we learned in last week. Compressed spring. What energy store in the spring? Yes, Zihua, this is elastic. Okay, elastic energy store. Okay, so at here, when we release, the spring will trying to go back. Okay, this is compressed, so it will trying to go back to original shape and size. So the spring will expand. So what energy will transfer to? Okay, so starting is elastic. Okay, so from elastic energy store to what energy? Yes, Zihua say kinetic. Yes, kinetic energy store. Okay, so for this part, kinetic energy store is because of the trolley moving. Then this one, elastic energy store is because of the spring. Okay. Okay, can we go to the page 11? Crystal, okay, Xuan, have you finished? Question 5. Xuan, okay. Okay, like boys and girls, this is a simple question. Okay, battery power torch. Okay, this show the energy transfer when the torch is switched on. Okay, so starting, what kinds of energy store? Starting energy store is, what do you think? Chemical. Yes. Why chemical? Why is why is chemical? When we switch on, okay, the torch will working is because of what? Battery, yes. Zihua say cause the battery, yes. So chemical is because there is a keyword called battery. So battery at here, it will convert to what energy? So here going straight, this is the useful energy. Here thermal. Torch, do you want thermal? You want the heat? No, so thermal actually is our wasted energy. So what is our useful energy here? Okay, Zihua say light energy. Yes. So write down light energy. Okay, light energy. So at here, another thing, starting is 100 joule. Some of the energy, 70 joules, goes to the light. Then the rest will goes to the thermal. So 100 joule minus 70, we understand there is a 30 joule of energy is wasted to the surrounding. Very good. Okay. So this is to tell you that principle of conservation of energy. Okay, can we go to page 12? Page 12 is the same things. Viton okay, Megan okay, Crystal okay, good job. Okay, here you have to read the question and then you have to think what kind of energy we have. Okay, so here, electric motor. Okay, it will pull electric. This is electric. Switch on the electricity, electric. Okay, then pulley wheel being used to raise. Keyword at here. Can you highlight? Okay. Leaf raise, that means that it moving up. Okay. So here electric motor use a belt to turning. Okay, turn. So highlight. Okay, so at here when the electric motor leave, here keyword. From here we also can know when it leave. Here leave, highlight leave. It will transfer energy. So figure 4.2 shows the energy transfer. Write on the figure 4.2 to complete the label. Okay, so starting is electrical. It's not chemical because we are not using battery. We are using electric. Okay, we switch on electricity. It's not a battery motor, okay? It's not using battery to switch on and trigger to let the motor to work. No, it's electrical energy. So here they tell you that this part is useful energy transfer. What is the useful energy here? We got two forms. Can you tell me? 子花 get the answer correct. Wait, let me. No, second one is wrong, 子花. First one is correct. How about others? Any others? Y10, tell me your answer, Megan. Crystal, one is correct. Another one? Licious, correct. One more. Licious, one more useful energy. What is that? So most of you can tell me that one of the energy actually is GPE. Okay, gravitational potential. But there is one more useful energy. What is that? Correct. Teacher say kinetic. Why? Just now it's here, turning. Okay, it will move what? Turn means that it will move. So here, raise or leave. This from this sentence, keyword, we know that GPE. Turning is moving, is kinetic energy. Okay, so at here, what is the wasted energy? Only one. This is very little. But here is only one box, so we won't write this. The man wasted energy, it should not be a sound. Man wasted energy, it should be 实话 correct. Thermal. Okay, if only one box, thermal is our answer. This is the most wasted energy. Then sound maybe is just a little bit, but here there is only one box, so we don't write sound. Okay, if there is two boxes, then we write thermal energy plus sound. No problem. Okay, so this one is read the question to identify what is the energy transfer. Okay, if no question, we goes to page number 13. Is it okay? We thought okay, Crystal, okay. Okay, so boys and girls, I want to read the question and then 1 minute, no only 1 minute, 30 seconds. Okay, can you try and then fill in the blank? Then you tell me your answer. I go and get some water. I'm so thirsty. You try with this question, Let me check your answer. Megan, first one correct. Second one, third one, and fourth one. 30 seconds, read the questions. Then you tell me your answer. Megan, second correct. Correct. Third one also correct, Megan. Last one correct. Good job. How about others? Precious, Hui-Tong, Crystal, Zihua. From the keyword, then we will know. I think not that hard. Hui-Tong, Megan. Oh, Megan already done. Zihua correct. Crystal, second one, third one, fourth one. First one correct. Okay, here, keyword. Find the keyword. From here, I understand what is the energy. Gravitational potential. Okay, at the top, keyword at the top, highest position. So this one is highest position. Okay, this energy, GP, actually is at maximum. Because this is at top, highest position already. So energy is maximum. Okay, as the arrows falls. So that means that your GPE will start to decrease. Okay, it decrease. So decrease, then the energy is converted into kinetic energy. Okay, it start to decrease and then kinetic energy increase. Falling, object falling, it will accelerate because gravity pulling. Okay, when it hit the ground, the energy will be converted to thermal energy, lost to the surrounding. When hit the ground, it's no longer moving, no height, no position. Okay, at lowest position, so no kinetic energy, no GPE. So where is the energy going? Going to the surrounding as thermal energy. Okay, is that clear? We talk okay. So if okay, we goes to the page number 14. Okay. So before we discuss, so 30 seconds again, I want you to think. Read this question for A. Do for the question A. Let me check Zihua answer. Zihua, 4 question A. For part A, 4 question, you score 3. One of the answer is wrong. How about others? We tell Megan try and then tell me your answer. If you didn't tell me your answer, I don't know whether we are too fast or you haven't digest the question. Crystal, let me check. Crystal also 4 questions. 1 question is wrong. Megan and Megan try. One more student answer me, then we discuss. Crystal still incorrect. Hui-Tong, one of the answer is wrong. Megan, one of the answer is wrong. Okay, dear, none of you get all correct. So we study about this. W. Okay. The weight. When the weight going down, accelerate because we release. W release, so it accelerate downward. So here, the W accelerate downward. So when it downward going down, WGPE will decrease. Yes. So this one is decrease. This one, everybody answer correct. Okay, kinetic energy. That means that the speed, okay, related with the speed. So accelerate, because accelerate. So I understand this one increase. This one also no problem. Everybody answer correctly. Okay, what happened to the GPE of F? F is this part. Okay, when turning, this one going down, going down, going down. Okay, this part actually is related. Okay, it's touching what is touching. So that means that this part actually is also moving. Okay, turning, it will turn. Okay, it's free to rotate, so it will turn. Okay, but here the question asking you what happened to the F GPE of force of F. Okay, GPE of F. So that means that this part, what happened to the GPE? So when this one going down, will this falling? Will this falling down? My answer no. It's just turning. Okay, it's connected with this axis. So at here. So when it moving downwards, actually it's make the F is rotating, but it doesn't decrease the position. Okay, it doesn't decrease the position. So we cannot say that GPE increase or decrease. It's actually constant, nothing change. Okay, nothing change. Remain the same. Okay, so what happened to the kinetic energy of F? It will turn what? Okay, it will turning, rotate. You see, keyword at here is rotate. The F is rotate. Rotate is moving. Moving, that means related with kinetic energy. Okay, so at here, so when the W accelerate downward, so speed increase. Okay, of course, this one is related and connected, so it will be rotate faster. So this part should be increased. Kinetic energy should be increased. It turns faster. Okay. What happened to the kinetic energy of W when it hit the ground? It already hit the ground. Okay, so what happened to the kinetic energy? Hit the ground. What happened to the kinetic energy? Any of you can tell me? Let me check, Crystal. Transfer to the thermal energy. Yes, transfer to the thermal energy. It actually goes to the surrounding as the thermal energy. Okay, when it hit to the ground, so the energy, kinetic energy of W will transfer to the surrounding as the heat or sound. But mainly is the thermal energy. Okay, can be thermal energy and sound, no problem. What happened to the kinetic energy of F after W hits the ground? W hits the ground. What happened to the kinetic energy? Increase, it will become faster, turning faster. After W hits the ground, will the F move faster, turning faster. Crystal correct. Y10 correct. What happened to the kinetic energy? Decrease. It will turn decreases less speed, then at the end it stop to rotate. Okay, at the end it stop to rotate. So here they also accept the answer if you mentioning about like it become the thermal energy. They also accept. Okay, so we goes to your page number 15. We goes to your page number 15. Okay, state the principle of conservation of energy. This is 2023, 2 years ago, the past year question. So here we say that energy cannot be created or destroyed. Okay, energy can only transform from one store to another store. Okay. Total energy remains constant. Energy cannot be created, cannot be destroyed. It's actually only transferred to others form only. Okay, other store from one store to another store. Okay, 10 seconds for you to complete this definition. Okay, I think should be done. Okay, figure 2.1 shows the energy flow diagram for a car powered by a petrol engine. So at here, petrol. So that's why we start with chemical because keyword of petrol, okay? So starting petrol energy, chemical energy store will convert to kinetic. Why kinetic? Because this is a car, it will move. So this is a useful energy. Okay, it will move kinetic. But of course, not all the energy will go to the useful one. It might have some wasted energy. So at here, the wasted energy is the thermal energy store and sound. Okay, so calculate the percentage of the energy transfer from chemical to kinetic. So how many percent at here? Easy one, right? Okay. Crystal correct. Zihua, how about how many percent? Starting input is 100. Yes, correct. Starting 100, wasted 70. That means that this one should be 30%. Okay, 100% minus the 70%. So we get 30%. 2 mark, please show the working step. If you didn't show the working step, you lose the working step part. Okay? Megan, correct. Okay, so this is the energy flow diagram for an electric car. Okay, electric car is driven by an electric motor which is powered by a battery. That's why at here is chemical also because battery. Okay, then we got kinetic energy, we got the internal thermal energy. Use the information in figure 2.1 and 2.2. State which car is more efficient. Efficient means what? More useful output. Okay? So you are the consumer, you want to buy the car. So which car you want to buy? Which one is more efficient? Choose the car. It should be easy to choose one. You just compare. Which one actually you want to buy? None of you can answer me? Zihua correct. Crystal said electric because it releases less thermal energy than the car powered by a petrol engine. Yes, but I want you to tell me less thermal energy. This thermal energy is useful, or you want less useful output energy or less wasted output energy? Okay, Megan, you ask yourself, you want the car is because you want the car to move. Okay, you want the car to move. Okay, so your answer say battery. Oh, yes, 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 correct, dear. Megan, correct. Crystal, yes, you have to mentioning about it has more useful output energy or you want less wasted energy. This is the keyword. Okay, of course, compare from the diagram, I know that it will have less thermal energy, but why you want a less thermal energy? It's because I want less wasted energy. Okay, of course, we compare, we understand battery, the car with the battery is having a less thermal energy. But if you're answering because it has less thermal energy, I can't give you much. It's because you didn't tell me why you need less. Because less thermal energy is less wasted energy. Okay, so we try here. Car with battery. Car. Um, car in figure 2.2, okay, which is using the battery one. Okay, so at here you can say that because it's producing more useful output power, which is the kinetic energy stored 70%, or you mentioning about less energy wasted. So thermal 30% of thermal energy stored. Thermal 30% of only 30%. Okay. Or you want to mentioning about the more useful output power, output energy also can. Okay, more useful output energy. Okay, it goes to the last page, page 16. Is it okay? Can we go to page number 16, question 11? Okay, Crystal, okay. A drone is a machine that can fly. Figure 4.1 shows rising into the air, lifting a camera lift. The drone obtained the energy from a battery of a cell. Complete the sequence of useful energy transfer as the drone rises into the air. One part is done for you. Okay, so let's start at here. Easy, right? What you starting with? Battery. So chemical. Then the circuit it will run, so it will make the electrical energy. Okay, then after that, here another keyword rise. So that means that we are going to GPE. But of course, it's rising, is also moving what? So at here, if you say that is kinetic energy, also correct. They accept with these two answer. Okay, it's also moving what? Going up, moving. Okay. The drone can move in any direction, up or down, backward or forward, left or right. It can also remain stationary above the ground. Describe the motion and positions of the drone when it has a large quantity of potential energy. Okay, describe the position. Large quantity of potential energy. Potential energy is due to the position. So from here, can you describe? the position right now when it has a large quantity of potential energy and small kinetic energy. Can you describe the motion? Okay, kinetic energy is due to the motion. So can you describe how it moves and at what kinds of position? Any of you? Any of you can answer me? None of you? Actually, I already give you all the hints. What? Potential energy is due to the position at large amounts of GP. That means what kinds of position it achieves right now. Okay, small quantity of kinetic energy. Kinetic energy is due to motion. So you have to describe the motion. If I say only small quantity of kinetic energy, so what happened to the motion? How it move? Move fast or move slow? Position is high position or low position? What happened to the height? Any of you answer me, answer me, please. 子花嘞，子花，伟通，Crystal。GPE at maximum. GPE at maximum. That means that at maximum height, position is at maximum height. Because GPE is maximum, so I know the position is actually at maximum height. Okay, small quantity of kinetic energy, that means that in moving slowly. Okay, so these two. When the drone moved, it wasted some energy. What kind of energy is waste? State the form of wasted energy and describe what happened to this energy. Okay, so we understand, and I told you most of the case, the main wasted energy actually is called thermal energy. Okay, what happened and describe what happened to this thermal energy. This thermal energy is actually dissipated to the surrounding, goes to the surrounding, lost to the surrounding. Okay, so we finished lesson number 18. We are going to continue lesson number 19. Any question? He is at maximum height and moving slowly. Very good. Thermal is dissipated to the surrounding. Yes, perfect. Okay, can we continue to your lesson number 19? Do some calculation. So basically, we will do calculation based on two. One is called kinetic energy. Another one is called GPE. Okay, kinetic energy is due to the motion. As long as it's moving, so it will have kinetic energy. So kinetic energy is 1/2 mv squared. Okay, so boys and girls, the square is only for V, it's not for the M. You don't 1 over 2 times M times V, then at the end you square it. No, it's 1 over 2 times M times V square. Okay, what is the energy unit? This energy unit is called joule. Okay, joule. Joule is an SI unit. Since it's SI unit, please make sure your mass must be in SI unit also, kg in kg. So your velocity is meter per second is also in SI unit. Okay? So here, an object with a mass, underline kg. So this is m mass. With a speed, this is v, 5 meter per second. What is this kinetic energy? So kinetic energy is 1 over 2 mv squared. You need to have the habit, write down formula, substitution, final answer with unit 3 step, okay? So 1 over 2 times 6 times 5 square. Square is for the 5 only. Press your calculator and then tell me how many joule. This is for the first question. Yes, Zihua already get the answer, 75. So you need to press your calculator. Make sure you know how to press it. Okay, can you try our past year question 2023, 2 years ago? A woman with 50 kg, write down m kg. So I know that is measuring the mass. 81 joule is the energy, kinetic energy. Can you calculate the speed? Okay, do your calculation right now. 回通 C, correct. 1.8 meter per second. You don't wait for the answer, you have to press. I want to make sure you know you need to square root it. This is mathematics. Answer C. Okay, we go to question number 3. Calculate the velocity V for a mass 500 gram. Kinetic energy is 400 joule. Now, boys and girls, you try. Calculate the velocity right now. Huitong, no. Huitong, no. Zihua, yes. Huitong, did you convert 500 gram?
Yes.
Oh, yes. Oh, Zihua done. Huitong. Now it's Huitong. Huitong, your answer is wrong. Maybe got two reasons. One is, did you convert 500 gram to kg? And then second one, did you square root it? Megan, correct. Okay, so at here, V square, 500 gram, you have to convert become 0.5 kg. Convert it into kg, this one in kg. Okay, at the end, you need to remember square root your answer. So if you do everything correct, your answer should be 40 meter per second. This question is to test you. Do you understand that? Do you know that you have to convert to SI unit? Why need to convert to SI unit? Because joule is in SI unit. Okay. Okay, if no question, we go to question number 4. Answer is 40 meter per second. Question number 4. A car of mass 2,400 kg moving with a velocity. So this is starting velocity 20 meter per second. The driver apply the brake and velocity decrease to 10 meter per second V. In 5 seconds, this is the time. Find the kinetic energy, initial kinetic energy, starting kinetic energy. So can you do calculation? What is the answer you get? Initial, that means that's starting. So your velocity also need to take the starting energy. So I should using 20. Instead of 10, I should using 20 starting energy, starting velocity. So if you do everything correctly, 4x 0 joule. 480,000 joule. Okay, next I want you to calculate the final kinetic energy. Final kinetic energy, so you should using the final velocity. 此花 A correct. Okay, B do it. Yes, correct. You need joule. Okay, you have found that initial is 480,000. Final only 120,000. So that means that the energy is losing. Can you count the loss of kinetic energy? Okay, starting is higher, then at the end we only left 1,200. So the loss of the kinetic energy losing. So we can calculate 4x 0 minus 120,000. So we'll get 360,000 joule. Yes, correct. What happened to this energy loss? This energy loss, where it go? What happened? Crystal correct, yes. So what happened? Loss of this kinetic energy, what happened to the energy loss? Transfer into thermal energy and dissipating to the surrounding. Yes. Okay, so this energy loss is converted to thermal energy. Okay, is dissipated to the surrounding. So you can write more, dissipated to the surrounding. So at here, the car at the end apply the brake. Applying the brake, at the end speed can decreases. So at here, actually this energy, losing energy to the thermal energy is because it used to overcome the frictional force. Frictional force. Okay, this one you add one more sentence, say that this better to the surrounding. Okay. Why? And why it convert to thermal energy is because when applying the brake, they will have friction between the tire and the road. So the friction will produce thermal energy. So this is how we do calculation for kinetic energy. Then we are going to calculate the GPE right now. Is it okay? Can we? Crystal, okay, huh? Megan, okay. Xuan, do you able to follow? Do you able to follow? GPE is the energy stored in the object due to the position. Okay, write down position. Okay, so due to the height lah, position. So at here, GPE. So GPE, we can using formula mgh. Okay, mgh. So this one is also in unit of joule because this is energy what. So mass in kg, G is the 9.8 Newton per kg. This one, the value they don't tell, but we have to know by ourselves. Okay, 9.8 Newton per kg. The height is in meter. Okay, SI unit meter, mass in kg. Okay, here using the formula, a ball of 2 kg. So this one is mass. Falling, so I know this is GPE. GPE from a height. So this one is the height is h. What is the GPE? So GPE is mgh. Okay, GPE mgh. So mass is 2, 9.8 times the height 1.25. This question, nothing to trick you. Okay, press your calculator. Oh, this one I need calculator. Or somebody can press and then tell me the answer. 24.5, Crystal tell me 24.5 joule. Okay. So question won't tell you what is G. We have to know 9.8. We have to identify mass in kg. The height is in meter. That's all. Press your calculator, then that's all. Megan, 24.5. Okay, thank you. Okay, question number 2. Leaf. Keyword leaf. So GPE again. Then 2.5 kg, this is the mass with a constant speed at a height. Okay, so this one is the h. What is the GPE? Okay. Crystal is 29.4. Okay, thank you. Okay, this one also nothing to trick you. Okay, we goes to question number 3. Question number 2, 29.4 joule. Okay, question number 3. Don't take as 10. Like, help me to change. Take G as 10. This one is for the old syllabus. We're using 10. But starting from 2023, we're using 9.8. So we're still using 9.8. Okay, we're using 9.8 Newton per kg, or actually 9.8 meter per second square. Doesn't matter. Okay, so here, do your calculation. So Crystal give me. Crystal, we're trying to make it 2 to 3 significant figure. 3200. Okay. If 3 significant figure, it will be 3230 joule. So 2 significant figure, 3 significant figure. In our IGCSE, there will be, except you go and study the exam scheme, answer scheme, marking scheme, they will be always giving us to 2 to 3 significant figure. Then there they will say that with the suitable significant figure. Okay, 1 is not a good significant figure, but we no need to a lot. Just 2 to 3 enough. Okay, question number 4 is 2023, 2 years ago. So can you try? The rock of weight 50 Newton. Fall with a vertical distance 7 meter from rest. What is the change in the GPE energy store of the rock? So at here, there is a rock. Crystal B, correct. Okay, so at the highest position, 7 meter, this is the maximum GPE. After that, it falling until it hit to the ground, no more GPE. So what is the change of GPE? We just finding the GPE lah. Okay, from starting here, what is the energy? Then that is the changes until the end. We don't get any GPE anymore. So at here, energy for GPE is mgh. But teacher, I don't have the mass. I only got the 50 Newton weight. So weight is what? W equals to mg. Yes, correct, Crystal. W equals to mg. So that means this part is W. So your weight 50 already tell you mass and G. So times your height is 7. So your answer should be 350 joule. So answer A, B, or D. Now it's falling. Falling. Keyword is falling. If fall, that means that we are from the maximum, then become 0. So we are decreased. So answer should be B. So at maximum at here, maximum at here, 350 joule. Final at here is 0. So how much changes? 350 joule. Or I can write in this way, change in GPE due to the change in height. The height is 7 meter. Okay, the height is 7 meter. Okay, until here, any question? No question. We are going to page number 5 right now. Okay. Only Crystal say okay. Okay, here, conservation of energy. Just now we learned about theory from one form to another form, from one store to another store. Total energy still remain the same. Okay, so now we are applying with the formula to do some calculation. 1 kg of block moving down frictionless. That means that no friction. No friction, that means that no thermal energy, no energy loss as thermal energy. That means that perfect case, I will assume this is a perfect case. Okay, ask yourself, starting at point P, we have the 20 cm height. So this one actually is GPE. So here actually energy is GPE. The GPE, we will lose because from the highest position, we're going down to the R. So we will lose GPE and it will convert to what energy? It will convert to kinetic energy. So kinetic energy will gain. Okay, we write it down. We gain kinetic energy. We lost GPE. So at here, all the mgh will be converted to 1 over 2 mv squared. All the GPE will convert to kinetic energy. Okay, here, teacher 1 kg. Okay, 1 kg times 9.8 times the height 20. 1 over 2 times 1 times v square. What is your v square? Do you able to agree my substitution right now? Do you able to agree my substitution? Do you agree? Yes. No. There is something wrong in this substitution. Any of you can identify? Seems like everything correct, but no. There is one part is wrong. Any of you can tell me? Can identify it out? Zihua? Negative? No. All are positive. Nothing to get a negative. Unit, dear. Unit. As I told you, all this energy is in joule. It's in joule. Okay? So at here, 20 cm. Actually, we cannot straightly use. We should convert it into meter. So for this one, actually you should write 0.2 meter. So at the end, your answer at here, if you press calculator correctly, it should be 2 meter per second. See, in meter per second, it's not in cm. Meter per second. So this is the part that you need to pay attention. 子花 is supposed to be m. ms is what? It's supposed to be m, yes. Okay, so this is the perfect case. This is the perfect case. All the GPE goes to the kinetic energy. But some of the case is not perfect. Oh, MS miss. Yes, thank you. Okay, dear. So we try with this past year question. 2021. A stone is released. So a stone is released from the rest, from a high building on the earth. Air resistance is negligible, so no energy loss to the surrounding. No energy loss to the surrounding. Okay, what is the velocity V when it fallen 5 meter? From here to here is 5 meter. So you ask yourself, at starting, what is this energy? This is GPE. Then it converted to, at the end, at here, just before it touching to the ground, this is kinetic energy. So we will write down GPE, or we say mgh. This one will lose. It will gain kinetic energy. It will gain and convert to kinetic energy. So mgh, m is the mass. Okay. I write GPE loss equals to kinetic energy gain. So mgh equals to 1 over 2 mv squared. Okay, but the problem is here. Teacher, the past year question didn't give us the mass. How can we proceed to solve it? Dear, from starting to ending, is the stone or stone. At the end, still this stone. From starting to ending is still the same object. The mass of the object doesn't change. That means this mass and this mass actually is the same mass. Although the question doesn't provide it, yes, Zihua said it can be cancelled out. Yes, correct. So at here, m and m we can cancel out. Although the question doesn't provide it, but we still can solve it. 9.8 times the height is 5 equals to 1 over 2 v squared. So final v, what is your v? Do your calculation and tell me what is your answer. A, B, C, D. Okay, Crystal. Correct. Actually, if not mistaken, here you get 9.9 meter per second, right? But why this answer giving you 10 meter per second? Why not 9.9? Is because this is 2021. It's an old syllabus question. The question that in the old syllabus, their G, they're using 10. Instead of 9.8, here, this value, they're using 10. At the end here, your answer will get 10. That's why A, B, C, D. Here, B, they give you 10. Actually, it's because they are G using 10. Okay, boys and girls, do you still remember that? The four linear motion equation. The four linear motion equation, it should be, we have four linear motion equation. V equals to U plus AT. S equals to ut plus 1 over 2 at squared. S equals to 1 over 2 u plus v times t. V squared equals to u squared plus 2as. Actually, for this question, we can solve by using linear motion equation also. Okay, we can also using that method to solve. First, object at rest. So this one u equals to 0 starting at rest. Then going down, the distance s is the 5 meter. It's falling 5 meter. One more information we can know is our A, acceleration, 9.8 meter per second square. What they want you to find, final velocity V, USAV. So that means that we can using this formula to do calculation. If you're using this formula to do calculation, what is your V? At the end, you found out that you will get the same answer. So for this question, not only can solve by one method, but we have another method to solve it. Okay, one of the method is using the energy, conservation of energy. Another method is using the motion. Okay, the motion starting initial velocity is u equals to 0 is because the keyword of rest, from rest. So the distance, falling distance is 5 meter. We understand object falling down affected by gravity. The A is actually 9.8. So you can calculate your V. You will find out that the answer will be the same. Okay, until here, is that clear? Can we go to your page number 6? Okay, here. Question number 2. Oh, this one I wait. Okay, question number 2. A car starting from rest at position X. From position X, accelerate up a hill. The car reach a speed of 10 meter per second for the position Y. Then kinetic energy of the car at position Y is equals to its kinetic GPE, the energy it gained from X to Y. Take the GPE G as 10. Okay, we take as 10 now because this question also old syllabus. If you get 10, then you get the answer from ABCD here. What is gain in height? Okay, so boys and girls, can you try it right now? B, correct, B. Okay, answer is B, dear. Answer is B, 5.0 meter. You see, the final answer is giving us two significant figure. So if in the paper 2, don't trying to write 5 meter, 5.0 meter. Okay, Crystal B, correct. So dear, what is say that kinetic energy at position Y. So this one, kinetic energy at position Y is equals to the gain in GPE from X to Y. So that means that is same as the GPE. Okay, from X to Y, again, the GPE is equals to the kinetic energy. So we just, from this sentence, we know that mgh is equals to 1 over 2 mv squared. The mass and mass we can cancel out. Okay, because from starting to ending, we are same object. The car is the same object. Okay, then after that you do substitution, you get the answer 5.0 meter. Okay, is that clear, dear? Any question? Crystal, okay, If no question, then we will continue the rest of the question by next week. So we will stop our lesson right now. If you got question, then you ask me. If no question, that's all for our lesson today.